Now, in this lecture, we will see bus structures. Now, in a previous topic, functional units, I didn't show the connections between one unit to another unit. Now, here we will see how the different units are connected, different parts of the computers are connected by using the bus. Now, there are many ways to connect different parts inside the computer together. A group of lines that serves as a connecting path for several devices is called a bus. Now here you can see three different types of buses are available. This is the address bus, data bus, and control bus. Bus is nothing but what group of connecting wires. Group of connecting wires is called as bus. And these total three buses together we call it as a system bus. And this is a CPU, memory, IO unit, both input device and output device together here I have shown. Now, if you see, data bus is bidirectional because the data goes into the CPU and comes from the CPU, and memory data bus for the memory is also bidirectional. Input and output device also bidirectional. From the input, data comes into the CPU, and from the CPU to the output device, data goes. So that's why here you can see the data bus bidirectional. Now coming to the control bus. Control bus is also bidirectional. Now sometimes CPU want to read the data, sometimes CPU want to write the data. So if it is reading, it data control signals are going into the CPU as well as memory and IO unit. For all the devices which are inside the computer, this control bus is connected and it will control the complete unit. That's why this is also bidirectional. Now coming to the address bus, CPU assigns the address to the memory as well as input output device. Now here address is having only memory unit and input output devices. So whenever CPU want any data from the memory, then it will assign the address to the memory, or if it want data from the input device, then it will assign the address of the input device. If CPU want to write the data into the memory or write the data into the output device, then again it will assign the address to the memory or output device. That's why from the CPU only unidirectional address bus you can see. Now coming to the memory, always this address bus is unidirectional inside the memory. Why? Because the complete memory is divided into locations and each location is having its specific address. Without the address, we can't read or write the data from the memory. Now again, from the for input output, it is bidirectional. Now, if CPU want to write the data, then data goes to the output. If CPU want to read the data from the input, input comes from. And similarly, if input output devices want to write the data, read the data into the memory, from the memory, then it can also send the data and take the data from the memory. That's why here the address bus is bidirectional. Now there are two different types of structures are there. The first one is a single bus structure, and here address bus holds the address and the data bus holds the data, opcode, status. Apart from the address, whatever the information is there, that will be held by the data bus. Now control bus gives the control signals like memory read, memory write, input read, and input write. Okay. Now we will see the structures: single bus structure and double bus structure. In single bus structure, one common bus used to communicate between peripheral and microprocessor. Now, if you see here, input device, output device, memory, and microprocessor, here only the common bus is connected between all these units. And this structure is commonly used structure and it is very cheap and a simple design. But only the disadvantage is if any two units are communicating, other units should be idle. Here the performance speed of the system is slow. Now coming to the double bus structure. In a double bus structure, two buses are there. One bus is IO bus, which is between input output device to the processor, and another bus is memory bus, which is between processor to the memory. Now here one bus will carry the opcodes and one bus will carry the operand. Now here, because of a two bus structure, the cost of this structure is more compared to the single bus, but speed of the system will increase. Now here I have given the differences between single bus structure and double bus structure. You read, you will understand. Next, multiprocessor and multi-computer. Now this is the diagram for the multiprocessor. Here more than one processors are there and all processor are sharing the same memory. Now this is a multi-computer. So here processor, again four different processors are there, but four different processors are having its own memory, and this is called the computer, single computer, and these systems are communicating by using the message passing network. And with this we can increase the speed of the system, efficiency of the system will be increased. Now by using this multiprocessor we can perform the parallel tasks. If different applications are there, then the different processor will execute the different application. Or if only single task is there, then the single task will be divided into parts, and each processor will take care of each part. Thereby, what the system speed will increase. Now, with this, we have finished the today's topic.